dear students. Today we will discuss upon the Unit 4, which is the last unit. From here there will be 70% of theory and 30% can be numericals. So the first topic is soil structure interaction, or in short called as SSI. If you can see, the name of the Unit 4 is called as Geotechnical Earthquake Engineering, which means the relation between soil, earthquake and structure. It will include certain geotechnical part as well. Now, if you see soil structure interaction, SSI, there are two terms. One is soil, one is structure, and the third word is interaction, connecting these two. If we see a building, it will be constructed above soil, right? Now, soil structure interaction means during an earthquake, the vibration of the building, how it will affect the vibration of the soil, and how the vibration of the soil will affect the vibration of the building. That is the relation or the interaction between the soil and the building during an earthquake. During an earthquake, the building will also vibrate, the soil will also vibrate. Now, since they are connected at the foundation level, how their vibration will affect each other is simply called as soil structure interaction, or SSI. Now, there are basically three parameters on which soil structure interaction depends on. One is the stiffness of the building. Stiffness of building. Second is the dynamic property of the building. This dynamic property can be natural time period, can be omega, or can be other dynamic properties of the building such as damping. Okay, such as damping. Damping is denoted by C. And the other one can be the mass of the building. If the building is very huge with a huge mass, the behavior of the building or the vibration will be different and the effect on the soil will be different than a smaller building with smaller mass. Is it clear? Now, what we discussed is what is soil structure interaction, on what parameters it can depend on, and then we will decide what are the types of SSI. First objective is fulfilled, second objective is fulfilled, and the third objective is types of SSI. Basically, there are two types of SSI. One is kinematic interaction and the other one is inertial interaction. Now, if you see, for a building under earthquake, there are basically two major properties which we will analyze in SSI. One is the stiffness and other one is the mass. Now, when in a building or in the foundation of the building, the stiffness is more than the mass, that is, the stiffness is the dominant parameter, and because of the stiffness, the vibration in the building is happening, and that vibration will affect the vibration of the soil, and vice versa is called as kinematic interaction. That is, it depends on the stiffness of the building. And the second one is inertial interaction. In here, the mass is predominant. The mass is predominant and it will affect the vibration of the building, and furthermore, with that vibration will affect the vibration of the soil. That means in inertial interaction, the mass is the dominant character. So is it clear? Kinematic interaction depends on K, stiffness of the structure, and inertial interaction depends on the mass of the building. So for your level, types of SSI understanding up to this part is okay. Now the fourth part and the most important part is how soil structure interaction happens, the phenomenon. Part of this chapter's soil structure interaction is phenomenon of soil structure interaction, that is how soil structure interaction actually happen. It is important theory where you will have to also explain the phenomenon with a diagram. Now to understand it, we will assume a building with above soil. Now let that soil have a fault down there. Fault is nothing but the original point where the earthquake originates. Now let us assume there is an earthquake happening at this fault. When earthquake will happen, there will be certain seismic wave. Suppose E is generated. Now soil and building are two different materials. As the seismic wave travels through the soil and it reaches the building, certain part of this seismic wave will travel or get transmitted to the building, which we will name as E1, and certain part of this seismic wave will get refracted back to the soil. Let us name it as F0. Here I have written E is the seismic wave, E1 is the transmission wave, and F0 is the refraction waves. Now when this transmission wave of the earthquake E1 will travel in upward motion of the building will start to vibrate, and as it reaches the top portion of the building, again it will have a downward motion after that. Suppose F1, and after having the downward motion of the transmission wave, it will come back to the soil, suppose as R. Now there will be not only one wave, there will be different waves passing from the fault to the building, and this phenomenon will keep on happening. When the seismic wave will get transmitted to the building, and then certain part of it will get refracted back. Similarly, the transmission wave will travel downwards and thereafter to the soil. Meanwhile, from the vibration of the soil, the vibration of the building will occur, and from the vibration of the building, again the vibration of soil will happen. During this simultaneous process, soil structure interaction phenomenon occurs. Is it clear to everyone? For further doubts, you can read the PDF which I have given you for this theory, and for more doubts you can just ping me.